is alpha ij, I can bring this term to the other side, and what do I get? I get d by dt of mi vi dot del ri del qj plus, minus, so go to the other side, mi vi dot d by dt del ri del qj. Okay, so we've got an expression for delta ij. Time to work out our identities. You've all got them in front of you. What am I going to do with them? This should look familiar. Right, this looks like one of the identities. Indeed it is. Right, which identity? What is our number the identity that deals with this problem? Number 3. So by identity number 3, mi vi d by dt del ri del qj is simply del vi del qj. Right? Okay, that was one identity. There's another one. Just looking at this guy, del ri del qj, can you find an identity that transforms him? Look at number 2. Look at number 2. And it says del ri del qj is the same thing as del vi del qj dot. Right. This is mi vi dot. We're nearly there. We're nearly there. Now we have two expressions that look like vi dot del vi del something. Does anybody know what the next equivalent expression is? We've done this before. We did it when we were deriving kinetic energy. Hint, it'll still lead to kinetic energy. Vi dot del vi del something looks like a piece of a product rule, doesn't it? Let me show you why. Right, unfortunately we're running out of space. I'm going to eliminate this thing. This little block down here. I'm not going to eliminate the left hand side, it's going to need to space that to the right hand side at some point. Right, so I'll just write right hand side up here. Right, so let's have a look. If I'm taking del by del something, what should I call myself? X, I don't know, whatever, something. Sounds nice because it looks like it's equivalent. Of vi dot vi, what do I get? So some people are saying 2. Correct, right? I use the product rule. First differentiate this one times this one, then differentiate this one times this one. Right? So I get 2 del vi by del xi dot vi. Or let me write it the other way around to be absolutely consistent. I mean, it doesn't matter. This is the same thing as writing vi there. Shut things up. Vi dot. Right. So that's all I did. I differentiate partially here with pick something. So I can take the 2 to the other side, can't I? I can take the 2 to the other side. I can simply rewrite this as a half. Right? Here's an identity. Why did I just do that? Because of that. And because of that. Okay. Well, let's see what I get if I rewrite this. Equal. This is going to be d by dt of the A minus man is constant. It can go inside or outside. I prefer to keep it inside here. So it's a half. In fact, even a half I like to keep it inside. Right? So certainly I could put the half inside. It makes no difference. I could put the half there, right? So I'd like to put everything inside. I'd like to take my del qj dot, and I'd like to put half mi vi dot vi minus, again, I'm going to take the del by del qj out of everything. Del by del qj half mi vi dot vi. Well, that quantity has come up twice now. All right, it's almost like the kinetic energy, except the kinetic energy is summing it over I. So that's fine. We are going to sum it over I, aren't we? So, we have reached just about the final point. Let's see what happens when we sum this over I. This is alpha ij, right? But the right-hand side of the equation there, the right-hand side of the Ohm-Gauss law, is when we sum alpha ij over I and j and times by delta qj. Right, so let's do that. I'm going to erase this little relationship. Let's write that out over here in this block. So the right-hand side is equal to the sum over j. I'm going to take the sum over j out, just like I did here. The sum over j is something times qj, right? The something is what happens when we sum over I, alpha ij, delta qj. Well, let's replace alpha ij with what its value is. Oh, let's do a little bit. Okay. So no, we'll do that. Delta qj. Right. So let's replace alpha ij with its value. Alpha ij's value is d by dt del by del qj dot of this thing minus del by del qj of this thing. D by dt. I'm going to call this thing I'm going to call it Ti. Right, the same quantity. D by dt del Ti by del qj dot, right, minus the sum over I, putting the sum over I through both terms, del T by del Q J. Ti. Right, so that's alpha ij. Now, if I take the d by dt out of this, which I can, d by dt out of the sum, d by dt, and in fact I can even take all the derivatives out of the sum, so let's do this. The board's fault, name on the board. I have to erase this stuff then. Is that okay? Alright. So I'll write this out. Sum over I. I'll leave it how it was. Ti d by c. Okay, this is how it looks, right? This will essentially just substituting this thing into here. Now we're going to raise this thing, so we take on faith that we substituted it into there already. We unfortunately have limited resources. Right, so we've got this guy, and we now want to rearrange it. Right hand side in. I can take all the derivatives outside of the sums. D by dt is not dependent on I. Del by del qj dot is not dependent on I. I can take it out of the I sum, right? So I've got a sum over j. This first thing, I can take d by dt and del by del qj dot out of the sums. D by dt of del by del qj dot of the sum over I of Ti. qj out of the sum. Del by del qj of the sum over I of ti. All of this multiplied by delta qj. The sum over I of ti. That's the sum over I of mIVI squared. That's the kinetic energy of the system, and we call it T. So we write this as the sum over J of d by dt del T by del qj dot minus del T by del qj by del qj. Right, so that was quite a lot of ingenuity that went into transforming that right-hand side. We used a few identities, we did a few little tricks, but now it's done. We've got a transformed right-hand side, we've got a transformed left-hand side. We can equate them, right? So, in our generalized coordinates, the Allenberg's principle becomes the sum over J of, you know what? The sum over J of Qj delta Qj is equal to the sum over J of d by dt del T by del Qj dot minus d by dt by del Qj delta Qj. So, these are equal. Why did we do this again? Yes. And the test is open book, so I will not ask you directly this, but I will ask you contextual questions to make sure you understand. So in other words, it will be about this, but it will be not just revision. It is in the notes, everything's in the notes. Yes. All the things in the notes are about that. Right, so why did we do this? Why did we do this? Why did we bother? Why did we go through all this effort? What was the point? So we give it a constraints. And in particular, because when we worked it out over here, what was wrong with these guys? They're related. Are these guys related to each other? No. They're not. That's the whole point, right? Delta QJs are independent. They're movements in our generalized coordinates. What was our condition for generalized coordinates to work, to make sense? Our condition was very specifically stated that our generalized coordinates must not be related to each other by any holonomic constraints. In other words, these delta QJs can be varied independently of each other. I can do this. This equation holds for all delta Qj, any displacement that I choose. Just like this one holds for all feasible delta Ri. The feasible was the problem here. I've gotten rid of it. This holds for all possible delta Qj. Why is that cool? There's a reason. And here's what it is. I can choose my delta Qj's now. Let me choose delta Q1. Let me make a little displacement where delta Q1 is 1, delta Q2 is 0, delta Q3 is 0, and all the others are 0. For that displacement, what do I get? The sums go away. And I just get Q1 delta Q1 is equal to, sum goes away because Q1 is the only one that's non-zero, is equal to d by dt del t by del Q1 minus del t by, oh, that's a dot, del Q1. Right, so I get the equation. And if I did the same thing for Q2, I would get another equation. And if I did the same thing for Q3, I get another equation. In particular, all of this is times by delta Q1 as well. But what do? Delta Q1 is a small displacement, right? And I can cancel it from both sides. So, in short, I get this equation in motion. And I got it for the first one, but there was nothing special about the first one. I could have done the same thing for the second, or the third, or indeed for the ith one. This equation, very, very, very nice equation. We don't yet know how nice. That's called Lagrange's equation of motion. We've worked hard to get here. You'll be amply rewarded by the power, flexibility of this equation that we derived. So the ith component to generalized force is given by this in terms of the kinetic energy. We can rearrange this equation, and normally we write it in a certain way that I'll write out now. Normally we write out Lagrange's equation like this. I just take this to the other side. I just write Qi plus del T by del Qi is equal to another thing. D by dt del T del Qi. Right. The reason why I normally write this out is because I want it to look familiar like Newton's equation. I want it to look like F equals the derivative of momentum. So I can think of this like F, and I can think of this like the derivative of something that I'm going to call canonical momentum. In a very deep sense, this is much more momentum than the momentum we've seen before. In a very deep sense, this is really momentum. The thing that gets conserved in jet. Right. So this is Lagrange's equation of motion. This is what we're here for. This is really a beautiful result. Unfortunately, we are running out of time, so we're not going to be able to say how beautiful. It's unfortunate because it's kind of like we've done a whole lot of math and we don't really understand why. I therefore encourage you to look at the notes. In the notes, all of this is derived again, but I go one step further. I provide examples and I indicate why these are beautiful. We'll cover it again on Thursday. But before you leave, just be aware of this but. There's a lab on Wednesday. We're going to be solving a problem of a bead on a spinning loop. That problem is solved in the notes. Read that solution. Otherwise, we'll get to the lab together. Right, so read that solution. Make sure you understand it.